All right, welcome back to Mr. Holloway's Foundational Java Skills series. In this video, we're going to talk about Java primitives. We're going to delve a little deeper into variables as well. But before we get started, go ahead and like, subscribe, and comment, and hit that notifications button. And class is now in session. Let's get started. All right, in the previous video, I talked about variables. We talked about declaring and assigning values for variables. And we talked about something called an int, a double, and a string. And in Java, these things are known as primitives. Now, in Java, there are 8 primitives. There is something called a byte, a short, an int, a long, a float, a double, a Boolean, and a char. All right. Now, I want you to notice the size. So if you notice the size, and I do have them color coded as well. So the data types in green are all related. So we have a byte here, we have a short, we have an int. And if you notice the size of them, so this is 8 bits. Now, if you don't know anything about bits, those are units of measurement on a computer. So 8 bits would be smaller. This is 16 bits, 32 bits, and 64 bits. So if you notice, this is basically doubled. And so these are basically number values. And if you look at the values, this is a small value of can't be any smaller than a negative 128 to 127. This is 32,000 in the negative and 32,000 in the positive. And an int is negative 2 to the 31st power to positive 2 to the 31st power minus 1, so on and so forth. And this is 2 to the 61st power. So if you notice, these are all related, but they have different values. Now, why do you use certain numbers over the other? Well, in some cases, like in video games, or even in certain situations, you need larger numbers. You may need to save on space, and so a byte would be perfect. So if you have a project where you're not using any numbers that will come close to negative 128 and positive 127, well, you should probably use a byte. If you're not sure, probably the int is the way you should go. Now, in most cases in this video, we're going to pretty much use an int. We'll use a double, a Boolean, and those are going to be the primitive data types that I'm going to use all throughout this series. I may or may not use a few others. Okay, so let's take a look at the float. So let's look at the orange. So we have a float and a double. And again, these are simply decimals. So this is 32 bits. This is 64 bits. And if you need very precise numbers, double is really what you should use because it's has more decimal points. So that's kind of it with these. Again, we're going to pretty much use doubles in this series. You have a Boolean, it's typically 1 bit. A Boolean is basically true or false. It's a very small value. Chars are 16 bits, and they're basically just a letter in single quotes. And so if you saw my previous video, to declare a char, you just type the variable type. The variable name is a C, and then we're setting it equal. We're assigning it a value of A. All right, now let's look at some code just to kind of prove some of this stuff here to see if it's actually true. And we'll work with an int just to kind of prove that. Now let's look at the maximum value, because this is something like, I believe, like 2.1 billion or something like that. But we'll take a look at this. All right, let's switch over into Replit. Okay. So I'm going to declare a variable, and now we have to declare it. So we're going to say it's an int, and let's say, let's just call it num. I'm going to call it num, and I'm going to set it to a value of, let me see, I'm going to just do it. So I'm going to say 2, let me see if we go, let me see, I can go 2 billion, 2.2 billion. So that would be 2 billion, 1, 2, 3, 1, 2, 3. I think that's a billion. All right, so we have a large number. This number is actually bigger than than Java will allow. Okay. So let's see. So instead of printing hello world, we're going to just print out this variable num, and right away we're getting an error. And if you notice, it says data, the literal, so the primitive of type int is out of range. So right away we're getting an error because it's saying, hey, that number is basically too big. We can't handle that number. So let me just go ahead and click run anyway. So again, we're going to say it says integer number is too large. And if you remember, if we go back to the chart, it is 2 to the 31st. So if you look here, it's 2 to the 31st minus 1. Okay, so let's come back in here and let's correct this. And so I'm going to give it its proper value. So let's just do this. So the number is actually this number. So it's 2,147,483,647. So that's the maximum number. So I'm going to just paste this here. And notice ints don't do well with commas, so I'm just going to go ahead and get rid of this. Oops, and that should be 6.4. Okay, so now let's see if it'll print. Let's see, it's giving me an error already. Let's see. We're going to run. This should be okay because this should be the maximum value. And everything looks good. Not sure why that's appearing there. Now, let's go up to 48. So instead of 46, we're going to do 48 just to test to see if this number can be run. And we should get an error. Yep, and it's out of range, so it's too large. So we're 1 over. All right. So, and then let's just test the other range. So let's go to the negative side. And now that is a negative 2.1 billion. And this should run. And actually, you know what? That is okay. I think I missed a 7 there. Let's see. And we're going to go ahead and run that. All right, so that checks out. Okay, so we have coming back to the chart. These numbers are pretty much equivalent to the 2.1 billion. Now, if you need a larger number, you can actually do 2 to the 61st, which I don't know what it is, but it's a pretty large number. It's going to be double, so it's probably 4 billion something. But nonetheless, we're going to pretty much use ints. Now, the last thing I want to show you is out of the primitives, and just yeah, actually, let's just focus on this. So, so what I want to do is I want to find out the maximum number. And so Java has a way of telling me the maximum number I can get. And so I just want to just quickly show you this because this is pretty cool. I'm going to say integer dot max value. And so what that does, it's going to tell me the maximum value. And so instead of testing it out, let's say I didn't know what it was, I didn't have a chart. If I just ran this, it's going to tell me the maximum value. So I'm going to run, and there's the number. So it gives me the maximum number. Now, if you don't know what this means, don't worry about it. It's not super important at this point. Maybe if you're taking an AP class, this may be something you use. But in general, we don't necessarily need to know that, but it's a good tool to have. Okay, so we talked about the primitives. Let me come back to the slide. And so again, pretty much we're going to be declaring ints, doubles. We're going to be declaring booleans, and I think that's pretty much what we're going to deal with. Now, you may be asking yourself, where are strings? So a string is not a primitive value; it is a non-primitive, and with primitives, you know ahead of time. So Java knows, the interpreter knows what to expect with a primitive. So it knows if I declare a byte, it's not going to be any bigger than these numbers here. So it's not going to be any bigger than that. Now, with a string, it's a little bit different. It's handled differently. We're going to talk about strings a little bit later, but I just want to focus on Java primitives in this video. All right, that concludes this video. If you liked the video, please like, subscribe, comment, and hit that notification button. And I will see you in the next video. Class is now dismissed.